Okay, let me share my PowerPoint. Okay, so last week we were doing moment of inertia, and I showed you the formula sheet and the formulas, and we did example 1. Right. This was example 1. This is the first part where you calculate volume. Okay, so when you're calculating volume, that's how you go about it. It continues to get your answer there. So this is the first part where you calculate volume. You can just see that volume is pi x squared dy if it's rotating in the y-axis. Okay. And then the key part, moment of inertia, that's the formula there. And we did that. And we did that. So if you can see that my graph, it has an x squared somewhere on the graph. So my formula for moment of inertia is x to the power 4. So I said last week that if it's x to the power 4, we can separate to x squared squared. And then where there's x squared, I substitute and put 25 minus y squared. This comes from my equation of my graph. Now, Marvin, yeah.
Yo. Oh shit.
Sorry, let me just make my volume go up. I can't hear you very well. Okay. Sorry, what are you saying, Marvin? Did you say something, Marvin?
No, I wasn't saying anything. There was an accident. Sorry.
Okay. Cool. So, as I was saying, this is the final answer for moment of inertia, for example 1. Okay. And then in terms of mass, remember, when you get our answer, it will be in terms of density. There will be a rho there. Okay. So they might ask you to say, put your answer in terms of mass. Okay. If they don't ask you, don't do it. If they ask you, you need to do it. So in terms of density, in terms of mass, you just divide your answer by your volume. Then you put with an M. So this was example 1 that we did last week. We looked at example 2. Example 2, it had an exponential graph. So we're supposed to calculate the volume and also the moment of inertia. Okay, so as I've told you that many times, it's in 3 parts. So the first thing we did was sketch the graph. Okay, I emphasize that you need to know how to sketch graphs. Next thing, calculating volume. Now, calculating volume. How do we calculate volume? We know that's the formula that we use. We substitute and then we get our answer there. Okay, so remember there might be shell method for calculating volume. Okay, always keep that in mind. Shell method is when your limits are in the x and is rotating about the y, or maybe your limits are in the y, is rotating about the x. Okay, but in these 2 examples, where the limits are and the way it's rotating, it was the same. Okay, limits are in the x, rotating in the x, so that is the same. So this is volume. And then if you look for moment of inertia, this is how we start off with the moment of inertia. Okay, so okay, I see a hand up. Inez, excuse me.
Sorry, sir, it was just a mistake.
Sorry?
It was just a mistake.
Oh, okay. Cool. Um, so we continue with calculating moment of inertia here, and then we get our answer is that. Okay, so this was example number 2 last week. And I think I gave you this to do. Is that correct? Did I give you this as homework?
Yes, sir, you did.
Yes, sir.
Okay, good. So now I'm just going to go through the solution. Since it was homework, means you've done it at home. You can just check and see what you did. The first thing is just to sketch the graph. So this is a cos graph, a cos x graph. So you can see it says y is equals to 3 cos x. So the amplitude is 3. Okay, it casts a 3 here. And then if you look here, x intercept is pi over 2. Then they gave us a range between pi. If you look at the question, they gave us range. This is the range they gave us on the question between pi over 4 and pi over 2. Okay, so they gave us the range. So from there, you can see my pi over 2 and my pi over 4. Okay. You see, for reason best known to them, I need to try to figure out why they prefer using radians. See, so instead of using 45 and 90 degrees, they prefer pi over 4, pi over 2 in radians, not degrees. So you need to be comfortable with that as well. Okay, so this is the first part, sketching the graph, showing the shaded area and the representative strip. Okay, I'm supposed to put an X and a Y here on the top of my strip. It's not very important, but it would be just nice if you put it there. Like that. Okay. Then at the bottom, you put this delta X, bottom of your strip. Okay, so this is the first part, the graph. I think everything is clear here on the graph. I don't think anyone have any problems there. Let's go to the next part. So the next part is when we calculate volume. Okay, so you can see already that we are dealing with, it's rotating about the x-axis and the limits are in the x-axis. Okay, so if I'm calculating volume, we know the formula for volume, right? V is equals to pi y squared integral okay, so that's the formula for volume. Okay, and just to remind each other, if I always like to remind the formula for moment of inertia is rho pi over 2 integral of y to the power 4. Okay, so that's the formula for what do you call it, for that's the formula that we use for moment of inertia, pi rho over 2 integral of y to the power 4 with respect to x. Okay, I just put the formulas here, but the working is front. So let's go to the next slide. So this is calculating volume. Sorry. This is the first part of calculating volume. Okay. It's pi y squared dx, and our y is 3 cos x. So it's 3 cos x, which is squared. Now, if you simplify it to be 9 pi cos squared. Okay. Now, the good part is cos squared, it's in the formula sheet. Okay. If you integrate cos squared, it's in the formula sheet. So you can easily find it there. Okay. So far, everything should be fine, right? And remember, as I said, you guys did this, so just looking at your work and marking your homework. So if we continue with this, we're going to get, okay, so that's the answer there. Okay, any questions on the first part of volume, or maybe the graph? I'm going to move on to moment of inertia. So we're now calculating moment of inertia. Okay, remember I showed you the formula already, but I'll show you again just now. So that's our formula for moment of inertia. So if you look at this, we replace y with 3 cos x. Now inside we have a 3. 3 to the power 4 is 81. We can take it outside the bracket. We can also take the pi outside because it's a constant. We can also take the density outside the integral because it's a constant. Okay. Only thing you can't take outside is anything with an x. You can't take it outside. But density, which is rho and pi, they are constants. And the 3 to the power 4, which is 81, I can also take it outside. Now, here we're integrating cos x to the power 4. So you need to know how to integrate cos to the power 4, cos x to the power 4. Just like sine x or tan x or cot. This is all under module 2. Okay, so you need to know how to do this. I'm going to the next slide so that I'll show you how it's done. So this is how you integrate cos to the power 4. You separate to be cos squared times cos squared. And then where there's cos squared, you put half 1 plus cos 2x. Now, some people might write it like this. It will be the same, right? Okay. Okay, this and that is the same thing. Is that okay? There's no difference. Then if you expand, you're going to get this next step here. And then I decided to take 1/4 outside. So it multiplies what is outside. Okay. Now you might use a different method. It's not really like I'm showing you here. Me, I prefer to factorize the half. Now you can do it with the half inside. It's still okay. You don't have to exactly do the way I'm doing, but just have to do the correct way in a different method. There are different ways to do it. Okay. As long as I make sure that you are doing correct mathematical principles. So this is what I do. After I expand, I take the 1/4 outside. This 1/4, I take it out. Then I get to this step. It will be now 81/8. It was 81/2. Now from here, I integrate. And then I substitute and I get my answer there. Always remember that pi, you see this x here. If I put pi, just pi/2 as it is. But if you put pi/2 inside a trig, it will be 1/8/2, which is 90. Okay, so always keep that in mind. That's important. Basically, guys, this is example number 3, integration, moment of inertia. Any questions on that? We've done number 1, 2, and 3.
Sir, can you please go to the previous slide?
Okay. This one, yeah.
Yes, sir.
Okay. Okay. Any questions as people are looking at the slide? Is there any questions there? Yes, Masudu.
Sir, just for clarity, on the second equation of the slide, right? Did you use trig identities for the 1 plus cos 2x?
Okay. Do you mean this part here?
Yes.
Yes, use identities.
Okay, sir.
Use identities there in the formula sheet. Okay, thank you for that question. Okay, I guess there are no more questions, right?
Yes, sir.
So we have completed this. Okay, let me see if there's example number 4. Okay, there's no example number 4, right? So basically, this was everything on moment of inertia. Okay, so as I told you, just practice it. I think it's not hard. I think it's one of the easy parts on module 5. Remember, module 5 is quite long, it's got 40 marks. So I think this is one of the easy parts. Now, I'm going to show a new slide. Let me just share it. So this is the last section on module 5. Okay, depth of center of pressure. After this section, we actually think we are way ahead of, just looking at, we are way ahead of, I'm just looking at the PESA, and we are quite ahead of the PESA, you know, of what we're supposed to be in the syllabus, because after we finish this, we only have 2 sections, module 6, which has 2 sections. Okay, so it doesn't matter, it's a good thing. If we finish ahead of time, we'll use the other classes to do revision. Okay, so I don't mind it, or if you finish early, like we're ahead of time like this, we'll use the other modules to do some revision questions and all the like. But I would advise you guys, again, I apologize that I can't, as of yet, I can't get them. I can't get the classes that we've done, the recordings, I can't get them as yet, but there are some pre-recordings that are already there that I did before the classes. For each module, I did some pre-recordings. So you can go there and see. They're not the classes, but they're still almost an hour long as a normal class. So if you want to do some kind of revision, you need to do that. If you want to refresh on something, go to those pre-recordings and you find them. Okay, moment I get any recordings from the classes, I also post. Okay, already I saw like 1 or 2, 3 students have sent me some questions and I've responded to that. Okay, so again, feel free to do that. If you can't, if you ask, sometimes the lecture is easier because they are on campus and it's face to face. But if they are not, if you need me, I can do that for you. Okay, if you need any questions, any answers, I can do it for you. So, depth of center of pressure, basically, that's the formula there. Okay, it will be second moment of area divide first moment of area. Okay, and then here, you can see this is second moment of area and another different color. This is first moment of area. Okay, so in the formula sheet, they just give you like that. R squared dA and RdA. Now, something very important to take note. Y is the distance from the x-axis to the representative strip. Okay, so your distance from the x-axis to the, like the center of the representative strip or something like that, we'll call it Y. And then this R it is the distance from the water level to the representative strip. Okay, if you don't understand it because we haven't done it, it's okay. We're going to go through it and I'll show you what I mean by this, but at least remember this. Okay, Sabelo, you have a question? I see you unmute. Or it's a mistake?
Oh, say it's a mistake.
Okay, I think just a mistake, right? So that's okay. We can continue. So, as I was saying, that this is Y and this is R. Now, for dA, it will be 2x dy. Remember, normally, in a normal case, our dA, it will be x dy, because our limits are in the y-axis. We're dealing with the y-axis, limits in the y-axis. So, normally, dA will be x dy. Okay, but you see that in our case, it's 2x. The simple reason is that we have, our shape is cut in 2. So we have 2 parts of the same shape. That's why it's 2x. It's like you're calculating 2 areas. Okay, so that's why there's a 2. Now, the shapes that we're going to be dealing with for this section of module 5, we have a trapezium, a parabola, a rectangular, triangle, and a semicircle. Now, this is the order of, if I can say, popularity, meaning that the one I know is most asked is the trapezium. After the trapezium is the parabola, and then after that is the rectangular, and then triangular. So the most common is the trapezium. The second most common, according to me anyways, I've never counted how many questions asked for trapezium, how many for parabola, but I've just done a rough estimate, you know. So trapezium, and then parabola, and then rectangular, triangle, and semicircle. Okay, I think we know the shapes, but I have taken the liberty of showing us how the shapes look like. Just taking a note of what we're doing now. This is a trapezium. Okay, you can see that now. The key thing here, how to explain this? There are two methods you can calculate depth of center. Okay, let me sketch the second. Now, this is the first option that you have. You draw your shape, the base of your shape, this base here, it will be on the x-axis. You see this base that I'm highlighting? It will be on the x-axis. Okay, and your water level, it should have a water level, right? It will be at the top. It can be anywhere at the top here. Or sometimes it can even be level with the top part. So this is one option. Okay, now I'm using this option only. Okay, I avoided trying to show the other option, but I'm thinking about it. Maybe next week I might show the second option. Maybe I'll just see if it's necessary or not. But what I think is, if there are two options, if I teach you guys one and you stick with one option, it's good enough. Okay, that's what I think. So the second option that we have, I'm going to see if I can do a quick sketch. So you have your, this is your, there you go, your y-axis, this is your x-axis. And then let me sketch. So you draw a trapezium like this. Okay, and then your water level would be on the x-axis here. Okay, this should be a straight line. Just hold on, guys, one moment.
Hey, Sabelo.
Sure.
Uqhubeke ndoda, sifuna ukuqhubeka thina slate.
Lo muntu lo usathethisa abantwana lapha endlini. Can't you see that I'm busy?
Yasa ngithi wena carry on baba, carry on. Ngathi uyayazi lena.
Yeah, for a sec.
Ndoda manje trapezium siyibhala ngaphansi kwama x-axis line.
Indoda angazi next. Angazi next. Futhi nje.
Uyayibona manje into enzeka la.
Sikhathini.
Yeah, ngiyatheka. Iphi
I'll show you.
ubheki kanti?
I'll show you video.
Guys, I'm back. I'm back. So if you look at the diagram, right, there are two options. You can put your shape above the x-axis, or you can put it below the x-axis. If you put it above the x-axis, your base should be on the x-axis, like I indicated here. Okay, I indicated here. This is where my base is. The base is on the x-axis, and then the water level is above. Now, if you want to put a trapezium below the x-axis, like this small diagram, it means my water level will be on the x-axis. The water level will be on the x-axis. Okay, so there are two options, okay, but I'm just going to stick with one option. I didn't want to, because they are like, we're going to do like 4 shapes. I didn't want to do 4 shapes, 2 options, meaning 8 calculations. That would be quite a mouthful. Okay, so this is trapezium. Next is parabola. Okay, it will be like this. Maybe the water level would be, sometimes the water level can be on the same as the top, or sometimes it can be a bit above. It can be above. It depends on the question. Okay, they should be, all this should be straight lines. Okay, forgive me, it's not a straight line that I'm drawing. So this is the shape of a parabola that you'll be expected to sketch. Next is a rectangle. It will be like this. And then after a rectangle, it should be a triangle. Okay, which is like this. Okay, so this is rectangle. This is parabola going back. This is parabola. This is rectangle here. And then triangle. Now, the last shape is a semicircle, but I've only seen one question for the past like 10 years. I've only seen one question. It came about, I think, 2 years ago, when they brought a semicircle. Okay, before I'd never seen it. So I included it here, but I won't even do it at all because I've seen one question only. Okay, I think good thing is it's part of the papers I gave you guys to practice.
Sir,
Yes.
is it possible that the water level is below the shape?
Sorry?
Is it possible that the water level maybe is below the shape?
No, it's not. It's not possible. Okay. Thanks for that question, Sabelo. The water level, it has to be maybe at the top, like on the same level as the top part, or it has to be some meters above. Maybe it can be 1 meter or 2 meters above the top. Okay. I've never seen a question where the water level is below the top part. And in fact, it's not possible. You see, this is depth of center of pressure is basically talking about canoes and stuff like that. So it's a bit tricky for me to explain to you what it is. Maybe next time I would put some pictures to show you the real life of what it is. Okay, but the water level can be below. It can only be level or above. Okay, so thanks for that, Sabelo. So let's look at example 1. Okay, now example 1 has got 3 parts. I'm just showing you the first part here. These are the second and third part. So the first part says a vertical plate in the shape of a trapezium I'm actually writing it down, so that I can see how fast you guys you write it, even as I'm doing it. Is installed in a demo. The top of the plate is 10 meters wide. So top is just write top is 10 meters wide. Okay, you don't have to write everything. You just say top is 10 meters wide and it lies 1 meter below water level. Then the bottom is 8 meters wide. So bottom is equals to 8 meters wide. And the height is 3 meters. So they're saying draw a sketch of the plate and show the representative strip that used to calculate the first moment of area and the second moment of area. So we're supposed to draw this sketch and show the representative strip. Okay. Now the example, it continues and says, calculate the relationship between X and Y as well as the area moment. Then 1.3 says, calculate the second moment of area as well as the depth of center of pressure. So 1.2, we're looking for a relationship between X and Y. Okay. And then 1.3, you're looking for second moment area. Plus depth of center of pressure. Okay, guys, so this is what we're looking for. Okay, I won't ask any questions because we haven't done anything yet, but I'm just hoping if you saw the questions, okay, that take a picture or write them down. So this is how we do it. What I did is I highlighted in red the key parts of this question. So the first key part is that it's a trapezium. You need to know what shape it is. Okay, let me be ticking as we're doing it, right? Showing you what I mean. So the first part is that it's a trapezium. The second part is that the top is 10 meters wide. The third part is that the top lies 1 meter below the water level. Fact number 4, the bottom is 8 meters wide. What happened to my mouse? Okay. You see, the bottom is 8 meters wide, and that this shape is 3 meters. So you can see the important things that I picked up. I put in yellow and I'm ticking. Trapezium, it's a trapezium. The top is 10 meters and lies 1 meter below water level, and the bottom is 8 meters wide, and the height is 3 meters. Now, all this is going to help me to do my sketch. Any questions on this? Okay, no, I expect not, right? So let's go. So the first thing you do, draw your Cartesian plane. Okay, your y-axis. So many people, they don't do it, and I don't know. I think I'm too much of a perfectionist in maths. Some things I want them there. A simple thing: draw your x-axis, your y-axis, and your origin. You can see my origins there, 0, 0. So always do that first. Now, they told us that the bottom is 8 meters. Remember, I explained that the bottom should be on the x-axis. Now, since the bottom is 8 meters wide, it is going to start from -4 to 4. Why? Because the y-axis, it bisects the shape in two. It casts the shape in two. So I expect my bottom side to be -4 and 4. Okay, next. That's what I was actually explaining here. to say the bottom is 8 meters wide, so we measure from -4 to 4. Okay, top is 10 meters wide, so we're going to measure from -5 to 5. Is that okay? So the bottom is -4 to 4 because it's 8 meters, we're dividing by 2. The top is -5 to 5 because it's 10 meters. Then you complete the trapezium by joining those lines. Now, they tell us that the height is 3 meters. It basically means that there's the 3 meters there, from the bottom to the top. So, what is that? It results in us having a 3 there. Any questions so far? Okay, so we have a trapezium. Now, this is our water level, right? Now, how do I know where the water level goes? They told me that the top of the well is 1 meter below the water level. So, let me use a different color. So this is the top of the well. You see this here. This is the top of the well. Now it's 1 meter below the water level. You can see the one meter. So it means the water level is at 4. If the top of the well is at 3, the water level is at 4. Why? Because the top of the well is 1 meter below. Okay, so you need to understand that part, how we get where the water level is. They told that the top of the well is 1 meter below the water level. So if my top is at 3, my water level is at 4. Does that make sense so far, what I've done? Any questions before I go? Just on this part of sketching, this is just the sketching part. Now, as you're thinking of a question, I'll continue, right? I've put my representative strip in the y-axis, as you can see, because when I'm doing this, our strip is in the y-axis. Now, remember when I was telling you that, what did I tell you? I told you that dA is equals to 2xy. 2x dy. Now, this one area here, let me shade it in purple. This one area here.
Please, sir.
You can calculate it using x dy. But since there are 2 of them, because it is divided, there are 2 of them. That's why I put a 2x dy. Okay, that question has come quite often, so I had to explain it. So guys, this is the shape, right? Now, something important. If you remember the first page, I told you that the distance from the x-axis to the representative strip is y. So I'm showing it there. That distance from x-axis to the representative strip is y. So I've shown it there. If you look at the bottom right, you find it. Now, the distance from the water level to the representative strip, which is our R, it will be 4 minus y. Okay, because this is y and this whole distance is 4y. So in that case, this our y is stands like that. Yes, Kayowa.
Please, sir, why can't we draw the strip according to the x-axis?
Because when I'm looking for depth of center of pressure, it's like somebody trying to calculate. You see, this is the depth of center of, like you're calculating pressure in a liquid. Now, pressure in a liquid, it's measured, it's a height. Let's say this is the liquid here. The shape is a trapezium like this, and there's a liquid inside. If you're looking for pressure inside that liquid, you consider the height. You see, we consider the height from the x-axis. And for us to calculate that, we're actually going to use y, our limits y-axis. So it's quite tricky for me to explain to you, but just know that you don't use y-axis, not x-axis.
Okay, thank you, sir.
Okay, thanks so much, Kayowa.
So, sir,
Yes.
it means always the represented strip for in this case for trapezium will be the represented strip will be
Sorry guys. Who's talking? Is it Sabelo or Bunguke? Okay, I think Bunguke start first, right? Because I saw
yeah.
Sabelo is, yeah, you can ask.
Yeah, I'm asking, like in this case of trapezium, the represented strip will be always dy.
Yes, it's always in Y. Just like I was explaining to Kayowa, she was asking that, is it possible to have our limits in the X? I was like, no, our limits are always in the Y. And the represented strip is always in the Y as well.
All right, sir.
Okay, thanks. Any other questions?
So can you explain the r is equals to 4 minus y and the y?
Okay, thanks so much, Sabelo. Okay, basically, Sabelo is asking for me to explain the r is equals 4 minus y and the y. Okay, now before I explain, I'm just going to go, okay, I was going to go back to the first slide, but let me just try and explain it here. Now, distance from strip to my handwriting is bad, to x-axis. Okay, so the distance from this is y. So this distance, let me write it here. This distance is y, this one here. From my strip to the x-axis, it's y. Now I'm looking for r. R, it is the distance from the water level to the strip. This is my r. Okay, distance from the water level. Now, how do I calculate r in terms of y? I'm going to say r is equals to 4 minus y. Okay, because the whole distance is 4, this one here. So 4 minus y, this y here. 4 minus y is equals to 4 minus y. That will be our r. Does it make a bit more sense, Sabelo, or still confused?
I get it now, sir.
Okay. Thank you. So from here, so this is our graph, our final graph. So what we do, I go back to the formula. I want to show you the formula. So there it is. Second moment is r squared dA. First moment is r dA. So first moment of area, this is how we calculate it. Remember, our r is 4 minus y, our dA is 2x dy. So what you do is, you see in circle, I circle the x. I remove the x and make this a circular formula from, I need to calculate this x. You see this x, that is in circle. We need to calculate it. How do we calculate it? We come to this is our graph. So I need to find equation of this line here. Equation of this straight line here. I need to calculate that. Okay. Now that is a straight line. How to find the equation of a straight line? You find the gradient first, and then you use that equation. You get your answer there. Now, from this answer, I need to make x the substitute formula. So, guys, remember, just to recap, I'm dealing with this. I'm dealing with this shape trapezium. So I need to make this straight line substitute formula. Okay, there's no two ways about it. I need to make this straight line substitute formula. So if you have a trapezium like this, okay, and then you have maybe water level up there, straight line, you make this substitute formula. You make this side here, substitute formula, only this side. Why we do that is because that side is closer to the orphanage, or that line is closer to the right hand side. Okay, so we're dealing with that line because that is the right hand side. You're going to see when we're going to do an example for this trapezium, if it was a parabola, like this is a parabola here, it's like this. We calculate the equation of this part of the parabola like this. You see this part? If it's a parabola, if it's a rectangle, let's say this is a rectangle like this, sure. You just need the equation of this side here. We need the equation of this line only.
Thank you.
So this is what we do, guys. Now let's calculate equation.
Yes, you are. Yes, I'm a teacher.
See how we calculate the equation of that straight line. Okay, Now the key part is this. When I calculate the equation, this is what I get. But I have to make x the subject of formula. Okay. I have to make x subject of formula. That's what is important. Okay, let me see if we can finish this on time.
When do you need it back? If you can give it to me today by the end of the day.
Okay, what to do, guys, is let's just put it on pause. Okay, we won't be able to finish on time. Okay, so on Monday we'll start from here. Okay, I will introduce it again and I'll explain again what we did. Okay, I won't start just from here. I'll start from the beginning and I'll go fast again so that I can explain. But we have started depth of center of pressure just for you guys to know. That's what they're doing. And Monday we'll cover it. I don't know if you're able to finish, but we'll cover as much as we can on Monday on that. Okay, but I'll start from the beginning just to explain quickly through you and all the stuff. So guys, for today we're done. Thank you so much. Enjoy your weekend. See you on Monday.
Thank you, sir.
Thank you, sir. See you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank
Hey,
you,
it's
sir.
happened.
Oh, thank you, sir.